Most of the time, almost every day, there's a lot of possibilities. See answers that they face, we can really say there's a bunch of probability. What does it mean? What it signifies? What am I trying to imply? Statistics and probabilities. That's amazing. That's amazing. That's amazing. What's amazing? What's amazing? That's amazing. That's amazing. Oh, that's amazing.
Another day, another adventure. Hello everyone, welcome to another episode of Stats Amazing. I am your amazing host, Wendy, and today we will be going to explore once more the world of statistics. And for today's topic, we will be going to tackle about normal distribution. Are you all ready? Yes, you are. So, let's go. All kinds of variables in natural and social sciences are normally distributed or approximately distributed. Height, birth, weight, reading ability, job satisfaction, SAT scores are just few examples of such variables. Because normally distributed variables are so common, many statistical stats are designed for normally distributed populations. And now, let us proceed to enumerate its property. Vanessa, I'm giving you the floor.
Thank you, Wendy. Now, let me tell you about some important properties that we should remember in a normal distribution. As what Wendy have said in the definition of normal distribution, it is a probability distribution symmetric to the mean. And when graphed, it will form a bell-shaped curve. Now, in order to attain this, we should take note on the following properties of the normal distribution. The first property is, in a normal distribution, the mean, median, and mode are equal. Why? Since symmetric mans dapat equal ang both sides from the mean. Because if the mean, median, and mode is not equal, then the curve will not appear symmetrically. The next property of the normal distribution is the total area under the curve should be equal to 1. Why? It is for the reason that the curve will not fall under the x-axis. The third property is the normally distributed curve should be symmetric to the center. Because by the definition, the normal distribution is a probability distribution symmetric to the mean. Next property is, there should be exactly half of the values are to the right of the center and exactly half the values to the left of the center. Since the graph is symmetric, then we assume that each side of the graph from the mean is normally distributed or equally distributed. Next property is the normal distribution should be defined by the mean and standard deviation, where the mean measures the peak of the curve and the standard deviation measures how the curve stretches or squeezes. The next property is the normal distribution curve must have only one peak or unimodal. Why? Because again, the curve is symmetric. So kung duha iyang peak, dili na siya maporma og normal distribution nga graph, dili na siya curve, bell-shaped nga graph. And the last property is the curve approaches the x-axis but it never touches the x-axis and it extends farther away from the mean. It is mentioned in the previous property that the area under the curve should be equal to 1, for the reason that the graph should not fall under the x-axis. Now that we know or we familiarize the properties of the normal distribution graph, let us now proceed on the forms of graph. Yes, lahi-lahi silang forma, guys. First form of graph is when it is symmetric distribution or the data values are evenly distributed about the mean. So, ingani iyahang forma. Yani ang forma sa graph sa symmetric distribution. Note that a normal distribution is symmetric. Now, the next form of the graph is skew distribution. It happens when the data values fall either to the left or right of the mean, and it has two forms. First is the negatively or left skew distribution. Negatively or left skew distribution graph forms when majority of the data values fall to the right of the mean. So, ingani iyahang forma sa negatively or left skew distribution. Next is the positively skewed distribution. This happens when majority of the data values fall to the left of the mean. Ngani pud iyahang forma. Note that the tail of the curve indicates the direction of the skewness. Right is positive and left is negative. So let's see again the graph. So this one in the left shows negatively or left skewed distribution because its tail is on the left, and this one in the other side is a positively skewed distribution because the tail is on the right.
What a bunch of relevant information, Vanessa. That's really amazing. Okay, that's a joke. Okay, at this juncture, let us continue to stay attentive, for we will be going to dive more.
Now, let us talk about the mean and the standard deviation of a normal distribution. As we recall, one of the properties of standard deviation stated that the normal distribution should be determined or defined through its mean and standard deviation. The mean is the location parameter, while the standard deviation is the scale parameter. The mean determines where the peak of the curve is centered. And note that increasing the mean moves the curve to the right, while decreasing it moves the curve to the left. And this is how it will look like. Refer to the figure. On the other hand, the standard deviation measures how the graph will stretch or squeeze. Note that a small standard deviation results in a narrow curve, while a large standard deviation leads toward a wide curve. This is how it will look like if a standard deviation is small, and if this is also how it look like if the value of standard deviation is large.
Homeworks, exams, reports feels heavy on your own. The pressure, anxiety, and stress keeps pulling you from holding on, and life is useless to carry on. Stop. You are not alone. Talk to us at happycolors.com, where mental health is our priority.
That's Amazing is back. I hope that you are still alive and kicking while watching our show. Okay, so now let me give the moment to Mary Rose, for she will be discussing the formula of normal distribution.
Kamsamnida, Wendy. Your energy is really consistent. That's amazing. Okay, without further ado, let me discuss the formula of normal distribution. The normal distribution is defined as the probability density function f of x for the continuous random variable x in the system. As you can see on the screen, the formula is f of x is equal to 1 over the lowercase sigma times the square root of 2 times pi times e raised to the power of negative quantity of x minus mu squared over 2 times the lower sigma squared, where x is the random variable, the mu is the mean of x, the lowercase sigma is the standard deviation, and the pi is approximately equal to 3.14159 and so on, and the symbol e or the base of the natural logarithm is approximately equal to 2.71828 and so on. Therefore, the symbols pi and e are both constant, which means they cannot be changed or their values are permanent. To further understand the formula, let us apply using some examples. Example number 1. Calculate the probability density function of normal distribution using the following data. Random variable x is equal to 3, mean or the mu is equal to 4, and the standard deviation or the lower sigma is equal to 2. By the formula of the probability density of normal distribution, we can now find f of x by substituting the corresponding values. So here, we can come up with f of x is equal to 1 over 2, since 2 is our standard deviation, times the square root of 2 times pi, times e to the power of negative 3, which is our random variable, minus 4, which is our mean squared, over 2 times 2, which is our standard deviation quantity squared. So here we have come up with 1 over 2 times the square root of 2 times pi. So if you're wondering, ma'am, asa gikan ng 2? So the 2 is just the value of the standard deviation. Ato lang i-substitute, no? And then sunod, e raised to the power of negative 3 minus 4 quantity squared. So ma'am, asa naman po nagikan ng 3 o 4? 3, di ba mao man ni ang value sa atong random variable x, then ato lang gi-substitute. And also 4 is our mean. Over 2 times 2 squared. So this aman ni pud gikan ning 2 squared, ma'am. Gikan ra na siya sa standard deviation or the value of our lowercase sigma is 2. Kani pwede ra ni siya kaning 2 squared, pari-pariha ra ni siya sa variance, di ba? As you can remember from our past discussions, variance is just equal to the standard deviation squared or the lowercase sigma squared. Okay, so after substituting the values, we can now easily solve this using a scientific calculator. So according to my source, mas dali daw ni siya if ang atong gamiton nga scientific calculator is Casio FX 991ES. But since I only got Casio FX 82ES Plus lang nga calculator, so I will still show you how I use it.
Here is the demonstration of how I use my FX82ES Plus calculator. If you have the same calculator as mine, then this tutorial is for you.
First thing we need to do is to find the exact value of 1 over 2 times the square root of 2 times pi. Just click shift and then pi symbol, and that is equal to 0.19947. Next is to simplify e raised to the power of negative times the quantity of 3 minus 4 squared over 2 times the quantity of 2 squared. That is equal to e raised to the power of negative 1/8. Reducing it into its decimal form, we now have e raised to the power of negative 0.125. To find the e symbol, just press alpha and the symbol x10 on the bottom part of our calculator, and then click the x raised to the power of box, then input the negative sign and 0.125 inside the box, and that would equal to 0.88249. Multiplying both results will equal to 0.17603,165 or 0.17603 when rounded off. And that is our final answer.
So now, after successfully solving the example number 1, I will also give you a second example to further understand the formula of normal distribution. So we have here example number 2.
If the value of random variable is 2 and the mean is 4 and the standard deviation is 4,
then find the probability density function of the Gaussian distribution, or what we've known as normal distribution. So first is we need to find the given values, which is our x or our random variable is equal to 2,
our mu or mean is equal to 4,
and the lowercase sigma or the standard deviation is equal to 4. So, no, since kahibaw naman mo kung unsaon paggamit ang scientific calculator, if you're having the same calculator as mine, which is FX82ES Plus Casio nga calculator. So, dili na nako ibalik og demonstrate, no? Since mga bright man jud mo. Again, using the formula, we can now substitute these values. So, f of x is equal to 1 over 4 times the square root of 2 times pi times e raised to the power of negative times the quantity of 2 minus 4 squared over 2 times the quantity of 4 squared. So, same as example number 1, ato sa ni siyang buwagon from 1 over 4 times the square root of 2 times pi, ibuwag na to siya from e raised to the power of negative times the quantity of 2 minus 4 squared over 2 times quantity of 4 squared. And so first, we need to find the value of 1 over 4 times the square root of 2 times pi, which is equal to 0.099735. And the next is to find the value of e raised to the power of negative times the quantity of 2 minus 4 squared over 2 times the quantity of 4 squared. So, ato sa ni siyang i-simplify. Again, as what I've said, same lang sa example number 1. So, 2 minus 4 squared is equal to negative 2 over 2 times, ang 4 squared is equal to 16 man, so 2 times 16. And that would equal to e raised to the power of negative 4 over 32. Unya, so di pa man na siya sa, ato na siyang decimal form. Okay, so that would equal to
e raised to the power of negative 0.125. So same lang siyang value no sa example number 1. And that is equal to 0.882496. And then we will multiply it to 0.099735, which is the outcome of 1 over 4 times the square root of 2 times pi. So with that being said, the product of those two values is equal to 0.08801573856, or equal to 0.08816. No, ratag bidyukihan. So now, since you know how to calculate using the formula of normal distribution, let me pass the floor to Mr. Lord Ivan.
Mary Rose. Let us now talk about the standard normal distribution. The standard normal distribution, also called the Z distribution, is a special normal distribution where the mean is 0 and the deviation is 1. Every normal distribution is a version of the standard normal distribution that's been stretched or squeezed and moved horizontally right or left. While individual observation from normal distribution are referred to as X, they are referred to as Z in the Z distribution. Every normal distribution can be converted to the standard normal distribution by turning the individual values into Z-scores. A Z-score is a standard score that tells you how many standard deviation away from the mean an individual value lies. A positive Z-score means that your X value is greater than the mean. A negative Z-score means that your X value is less than the mean. A Z-score of 0 means that your X value is equal to the mean.
All normally distributed variables can be transformed into the standard normally distributed variable by using the formula for the standard score or Z-score. So, if you're wondering, how can we get the Z-score? We can get it using the formula Z is equal to X minus mu over lowercase sigma, where X is equal to the raw score, mu is equal to the mean, and the lowercase sigma is the standard deviation. For example, suppose the current annual salary of all teachers in the United States have a normal distribution with a mean of $51,000, a standard deviation of $6,000, and a raw score of $65,000. So using the formula for the Z-score, we can have 65,000 minus 51,000 over 6,000, and that would equal to 14,000 over 6,000, and reduce it into a decimal number. So it is equal to 2.33, and that is our Z-score. Now that you already learned how to get the Z-score, let me introduce to you the Z-table. A Z-table is a table that tells you what percentage of values fall below a certain Z-score in a normal distribution. As you can see on the screen, the Z-table on the left is a negative Z-table, which will be used when your Z-score is negative. On the other hand, the Z-table on the right is a positive Z-table, which will be used when your z-score is positive. So how to use the z-table? Step number 1. Go down to the row on the left side of the table with the first 2 digits of your z-score. Step 2. Go across to the first column with the third digit of your z-score. Step number 3. Find the value at the intersection of the row and column from the previous steps. Using our previous example, we will use that z-score to locate its percentage on the z-table. So our z-score is equal to 2.33. Since it is a positive z-score, of course, we will use the positive z-table. So, remembering the 3 steps, so step 1, we need to go down to the row on the left side of the table with the first 2 digits of our z-score, which is 2.3. Step 2, go across to the first column with the third digit of our z-score, which is 0.03. And lastly, we can now find the value at the intersection of the row and column of our z-score. And the value of our z-score from the z-table is 0.9901. Remember that the purpose of the z-table is to identify the percentage of the z-score. Therefore, we will multiply 0.9901 by 100, which is equal to 99.01%, and that is the percentage of our z-score. I guess we are now ready to standardize normal distribution. Here, I will give you an example for further understanding. Example: you collect SAT scores from students in a new test preparation course. The data follows a normal distribution with a mean score of 1,150 and a standard deviation of 150. You want to find the probability that SAT scores in your sample exceed 1,380. So the given values are: the mean is equal to 1,150, the standard deviation is equal to 150, and the x is equal to 1,380. So for the solution, step 1, we need to find the z-score of the given data using the z-score formula, that is, z is equal to x minus mu over lowercase sigma. Then let us substitute the values. So z is equal to 1,380 minus 1,150 over 150, and that is equal to 1.53. Step 2. Find the probability of this score using a z-table or find the p-value. We will use the positive z-table since our z-score is also positive. As you can see on the screen, the p-value of 1.53 is 0.9370 in the z-table. And now for the final step is to draw the graph. But before drawing our graph, I am going to discuss first the finding areas under the standard normal distribution curve. In finding areas under the standard normal distribution curve, a two-step process is recommended with the use of the procedure table. The 2 steps are: step 1, draw the normal distribution curve and shade the area. Step 2, find the appropriate figure in procedure table and follow the directions given. There are three basic types of problems, and all three are summarized in the procedure table. Note that this table is presented as an aid in understanding how to use the standard normal distribution table and in visualizing the problems. After learning the procedures, you should not find it necessary to refer to the procedure table for every problem. Shown on the screen is the procedure table. Case 1. To the left of any z value, look up the z value in the table and use the area given. Here is an example for problem 1. Find the area to the left of z, which is equal to 2.06. We are looking for the area under the standard normal distribution to the left of z, which is equal to 2.06. Since this is an example of the first case, look up the area in the table. It is 0.9803. Hence, 98.03% of the area is less than z, which is equal to 2.06. As you can see, the shaded part is from 2.06 up to the left side because we are asked to find the area of the left of z, which is equal to 2.06. Number 2. To the right of any z value, look up the z value and subtract the area from 1. For problem 2, we will find the area to the right of z, which is equal to negative 1.19. So this is an example of the second case. The area for z, which is equal to negative 1.19, is in the z table is 0.1170. And we are going to subtract it from 1. So 1 minus 0.1170 is equal to 0.8830. Hence, 88.30% of the area under the standard normal distribution curve is to the left of z, which is equal to negative 1.19. As you can see, the shaded area is going to the right since we are asked to find the area to the right of z. Number 3. Between any two z values, look up both z values and subtract the corresponding areas. Example for case number 3. Find the area between z, which is equal to positive 1.68, and z, which is equal to negative 1.37. Since the area desired is between two given z values, look up the areas corresponding to the two z values and subtract the smaller area from the larger area. The area for z, which is equal to positive 1.68, is 0.9535, and the area for z, which is equal to negative 1.37, is 0.0853. Subtracting the two areas would come up to 0.8682 or 86.82%. And that is how you find areas under the standard normal distribution curve. So now, we can be able to draw the graph for our example. The shaded part is going to the right since we are asked to find the probability that such scores will exceed 1,350. Hence, 93.7% of the area under the standard normal distribution curve is to the left of z, which is equal to 1.53.
Problem number 1. A survey found that women spend an average of $146.21 on beauty products during the summer months. Assume the standard deviation is $29.44. Find the percentage of women who spend less than $160. Assume the variable is normally distributed. So let us solve this problem. Okay, to solve this problem, let us identify first the given. So we have the mean, which is $146.21. We have a standard deviation of $29.44, and also we have $160 as our x. Step 1. Draw the figure and represent the area. So, aning nga part class, atong i-sketch ang normal curve nga nag-represent ni area. So, atong makita class nga ang middle line nga naa sa sketch, ga-represent siya ni mean. Unya, kanang naa sa right nga line mao na si x. Sa x, naa siya sa right na butang tungod kay positive man siya. Nya kanang gishadan silbi mauna ang area na ato ang pangitaon. So, after sketching, let us proceed in step 2. Step 2. Let us find the z value corresponding to $160. So, aning nga part class atong gamiton si z equals x minus mean divided by the standard deviation as our formula. So, the result of $160 minus $146.21 divided by $29.44 is 0.47. Hence, $160 is 0.47 of a standard deviation above the mean of $146.21. So, atong sketch ang z distribution niya. Aning nga part class atong makita sa atong screen. Ang mean sa z distribution kay si 0 kanang naa sa middle na kanang linya nga naa sa middle. Nya kanang line nga naa sa right mao na si z. Nakatotong gipangita dito sa step 2. Step 3. Find the area using the table E. The area of the curve to the left of z equals 0.47 is 0.6808. Therefore, 68.08% of women spend less than $160 in beauty products during the summer. Problem number 2. Each month, an American household generates an average of 28 pounds of newspaper for garbage or recycling. Assume the standard deviation is 2 pounds. If a household is selected at random, find the probability of its generating. A. Between 27 and 31 pounds per month. B. More than 30.2 pounds per month. Assume the variable is approximately normally distributed. Let us solve first the A. Step 1. Draw the figure and represent the area. So, kadumdum ta class, example number 1, maurag hapon ang ato ang buhaton. Atong i-sketch para ma-analyze na to ug unsay ato ang buhaton. Sa A class, ang atong mean kay si 28 pounds. Nya ang atong standard deviation kay si 2. Nya naatay duha ka x, sa x sub 1 which is 27 and our x sub 2 is 31. Sa atong pag-sketch class, our middle line is our mean, mo si 28. Nya sa x sub 1, ibutang siya before ni mean since si mean is greater than the x sub 1. Nya sa x sub 2, ibutang siya after ni 28 since mas greater than si 31 or si x sub 2 kaysa ni mean.
So, makita na to class din sa screen kung giunsa pag-sketch. So, kanang gishade na po color yellow, mo na sad na ato ang pangitaon, ang area ana nila. So, let us move forward for the step number 2. Okay, step number 2. Find the 2z value. Same lang gihapon class ang atong buhaton para makuha ang z value ni x sub 1 ug ni x sub 2. Atong gamiton ang formula nga z equals x minus mean divided by the standard deviation. So, atong nakita din ha sa screen class, ang result ug pilay equivalent ni z sub 1 ug ni z sub 2. So, si z sub 1 is equals to negative 0.5. Unya, ang si z sub 2 is 1.5. Maura gihapon ang steps class ug giunsa nato pagkuha adto sa example number 1. Step 3. Find the appropriate area using the table E. The area to the left of z sub 2 is 0.9332 and the area to the left of z sub 1 is 0.3085. Hence, the area between z sub 1 and z sub 2 is 0.9332 minus 0.3085 is equals 0.6247. Class, para makuha ang final nga area, i-minus si z sub 1 ni z sub 2. So, ang sa pag-sketch ani class sa ato z distribution, ang ato ang mean is si 0. Unyang ato z sub 1 is 0.3085. Ang ato z sub 2 is 0.9332.
Hence, the probability that a randomly selected household generates between 31 pounds of newspaper per month is 62.47%.
Let us solve for B. So, step 1. Draw the figure and represent the area. So, mura gihapon class, atong i-analyze ang problem, then atong i-sketch or graph. Then, mao gihapon ang atong mean si 28, then ang atong standard deviation kay si 2, and our x is 30.2. As atong paragraph class, ang shaded part kay naa sa right or after ni 30.2, since ang giingon man is more than 30.2. Okay, step 2. Find the z value for 30.2. So, mora gihapon class, ang atong formulang gamiton, si z equals x minus mean over standard deviation. So, we have z equals 30.2 minus 28 divided by 2, and the result is 1.1. Let us move forward to step 3. Find the appropriate area. So, the area to the left of z equals 1.1 is 0.8643. Hence, to the right of z is equals 1.1 is 1.00 or 1. So that 1.00 minus 0.8643 equals 0.1357. Mara gihapon class, we need to use an A table to identify the area. So, hence, the probability that a randomly selected household will accumulate more than 30.2 pounds of newspaper is 0.1357
or 13.57%.
So that would be all, class.
In addition, in knowing that individual data values vary about the mean for a population, statisticians are interested knowing the means of samples of the same size taken from the population vary about the population mean. In learning central limit theorem, we must be aware or we must know these important concepts. First, a sampling distribution of sample means is a distribution using the means computed from all possible random samples of a specific size taken from a population. Sampling error is the difference between the sample measure and the corresponding population measure due to the fact that the sample is not perfect representation of the population. When all possible samples of a specific size are selected with replacement from a population, the distribution of the sample means for a variable has two important properties. But what are these properties?
Number 1. The mean of the sample means will be the same as the population mean. Number 2. The standard deviation of the sample means will be smaller than the standard deviation of the population, and it will be equal to the population standard deviation divided by the square root of the sample size. I will give you an example for you to understand more about the concept of central limit theorem. A.C. Nielsen reported that children between the ages of 2 and 5 watch an average of 25 hours of television per week. Assume that the variable is normally distributed and the standard deviation is 3 hours. If 20 children between the ages of 2 and 5 are randomly selected, find the probability that the mean of the number of hours they watch television will be greater than 26.3 hours. So first, we have to write the given in the problem. The standard deviation there, or the sigma, is 3 hours. The n is 20, and the mean is 25 hours. Since the variable is approximately normally distributed, the distribution of a sample means will be approximately normal with a mean of 25. The standard deviation of the sample means is sigma x bar is equals to sigma over square root of n, which is 3 over square root of 20, and it is equal to 0.671. The distribution of the means is shown in the figure with the appropriate area shaded. Now, let us find its z-value using the formula z is equals to x bar minus mu over sigma divided by square root of n. By substituting to the given in the problem, it will be 26.3 minus 25 over 3 divided by square root of 20, which is equal to 1.94. The area to the right of 1.94 is 1.00 minus 0.9738, which is equal to 0.0262, and if we will convert it to percent, it will be 2.62%. One can conclude that the probability of obtaining sample mean larger than 26.3 hours is 2.62%.
Now, do not be confused on deciding what to use between this formula and this formula. Z equals x bar minus mu over sigma over square root of n is used to gain information about a sample mean. On the other hand, the formula z equals x minus mu over sigma is used to gain information about an individual data value obtained from the population. Notice that the first formula contains x bar, the symbol of the sample mean, while the second formula contains only x, which is the symbol of the individual data value.
Now we are up to in our last topic. And this topic is about the normal approximation to the binomial distribution. A normal distribution is often used to solve problems that involve binomial distribution, since when the n is large, says 100, the calculations are too difficult to do by the hand using the binomial distribution. Recall that a binomial distribution has the following characteristics. So this will just be a brief discussion about the binomial, the properties or the characteristics, since it is discussed in the previous topic about the discrete distribution. First characteristic is there must be a fixed number of trials, since we will only use the normal approximation when the n is large. Therefore, we should know the value of n, or the number of trials. Second is the outcome of each trial must be independent. Third, each experiment can have only two outcomes, or outcomes that can be reduced to two outcomes. For example, given in the previous topic, the experiment should only produce outcomes classified as success or failure, or if not success or failure, a yes or a no, a truth or a false, and so on. And last is the probability of success must remain in the same for each trial. Also recall that the binomial distribution is determined by the number of trials, n, and the probability of success, which is p. When p is approximately 0.5 and the n increases, the more likely the shape of the binomial distribution looks like that of the normal distribution. But when p is close to 0 and 1 and n is small, the normal distribution approximation is inaccurate. As a rule of thumb, the normal approximation is used when n is so large that np is greater than or equal to p, and times n minus p is greater than or equal to p. In addition, the correction continuity may be used in the normal approximation in condition that np is greater than or equal to 5 and nq is greater than or equal to 5. This is a correction. The correction continuity is a correction employed when a continuous distribution is used to approximate a discrete distribution. The continuity correction means that for any specific value of x, boundaries of x in the binomial distribution must be used. For example, if our x is 8, then we should use its boundaries, which are 7.5 and 8.5. Now, in solving the mean or in finding the mean and standard deviation in the binomial distribution, these formulas must be followed. The formula of mean in the binomial distribution is mu is equals to n times p, where n is the number of trials and p is the probability of success. And the formula of the standard deviation in a binomial distribution is equals to the square root of n times p times q, where again n is the number of trials, p is the probability of success, and q is the probability of other outcomes or probability of failure, wherein q is equal to 1 minus p. So to solve for the normal approximation to the binomial distribution, we should follow these steps. Step 1. Check to see whether a normal approximation can be used. Refer to that. How can we determine whether when to use a normal approximation? Well, we will again refer to the condition of n times p is greater than or equal to 5 and n times q is greater than or equal to 5. Step 2. Find the mean and standard deviation using the given formula of the mean and standard deviation in a binomial distribution. Step 3. Write the problem in probability using x. We should refer to the summary of the normal approximation in step 3. Step 4. Rewrite the problem by using the continuity correction factor and show the corresponding area under the normal distribution. Step 5. Find the corresponding z values using the z formula on the topic discussed by Mr. Aposejo. And for the last step, find the solution. Now, let me give you this example for further understanding about the normal approximation in a binomial distribution. For example, a magazine reported that 6% of American drivers read the newspaper while driving. If 300 drivers are selected at random, find the probability that exactly 25 say they read the newspaper while driving. So first, let us identify the given terms. So, P, or the probability of success, is 6%. Now, we convert it to decimal form by dividing it to 100. So, P is equals to 0.06. And N, or the number of trials, is 300 since they collected the data values from the 300 drivers. And Q is 1 minus P, or 1 minus 0.6, wherein Q is equals to 0.94. So now, let us solve for the normal approximation to the binomial distribution. Step 1, check to see whether the normal distribution can be used. So, let's solve first the value of n times p and n times q. So, n is 300 times p, 0.6, that is equals to 18. And n times q is n is 300 times q, 0.94, then that is equal to 282. And since this fit to the condition np is greater than or equal to 5 and nq is greater than or equal to 5, since 18 and 282 is both greater than 5, then the normal distribution can be used. Now let's proceed to step number 2. Find the mean and standard deviation. So let's use the formula of mean and standard deviation in the binomial distribution. The formula of the mean is again mu is equals to n times p, and our n is 300 times p, 0.06, is equal to 18. And our standard deviation is equal to the square root of n times p times q, or the square root of 300 times 0.6 times 0.94. That will be equal to the square root of 16.92, or 4.11. Now let's proceed to step number 3. Write the problem in probability notation. Since it is said here that exactly 25 say they read the newspaper while driving, so P of x is equals to 20. P of x equals 25. Now, in step number 4, we should rewrite the problem by using the continuity correction factor. See the approximation in Number 1, since P of x equal 5 fits in the approximation number 1 in the table of summary of the normal approximation. So, our x is 25. 25 minus 0.5. X is greater than 25 minus 0.5 and lesser than 25 plus 0.5. Or x is greater than 24.5 but less than 25.5. And then show the corresponding area under the normal distribution curve. So this is how it will look like if we will put our mean 18 and the continuity correction in our graph. Then let's proceed to step number 5. Find the corresponding z values using the z formula. Since 25 represents any value between 24.5 and 25.5, let's find the values of z. So our z sub 1 is equals to 25.5 equals 18 over 4.11, the standard deviation, and that will be equal to 1.82. And our z sub 2 is equals to 24.5 minus 18 over standard deviation 4.11, then that will be equal to 1.58. And for the final step number 6, find the solution. So the area to the left of z is equals to 1.82. Now let's find the value of 1.82 in the z table, and we will get 0.9656, and the area to the left of the z is 1.58. And when we locate it to the z table, it will give us the value of 0.9429. The area between the two z values is equal to 0.9656 minus 0.9429, and that will be equal to 0.0227 or 2.27%. Hence, the probability that exactly 25 people read the newspaper while driving is equal to 2.27%. So, sayo naman siya guys, no? Sayo naman siya class, masabot naman siya. And this is the end of my discussion in the normal approximation to the binomial distribution. Have a good day!
If all possible samples of size n are taken with replacement from the same population, the mean of the sample means denoted by mu x bar equals the population mean mu, and the standard deviation of the sample means denoted by sigma x bar is equals to sigma square root of n. The standard deviation of the sample mean is called the standard error of the mean. Hence, sigma x bar is equals to sigma over square root of n. The third property of the sampling distribution of sample means pertains to the shape of the distribution and is explained by the central limit theorem. But what is the central limit theorem?
As the sample size n increases without limit, the shape of the distribution of the sample means taken with replacement from a population with mean mu and standard deviation will approach a normal distribution. This distribution will have a mean mu and a standard deviation of square root of n.
If the sample size is sufficiently large, the central limit theorem can be used to answer questions about sample means in the same manner that a normal distribution can be used to answer the questions about individual values. The only difference is that a new formula must be used for the z values. it is z equals to x bar minus mu over sigma over square root of n. There are two things that we need to remember in central limit theorem. When the original variable is normally distributed, the distribution of the sample means will be normally distributed for any size n or any sample size n. When the distribution of the original variable might not be normal, a sample size of 30 or more is needed to use a normal distribution to approximate the distribution of the sample means. The larger the sample, the better the approximation will be.